Join us as we tackle a classical limiting reactant problems involving the reaction between silver nitrate and sodium chloride. We'll also walk through step by step as we calculate the theoretical yield of silver chloride from both reactant and identifying the limiting reactant. In the end of this video, we are going to determine the mass of sodium chloride present in the solution based on the collected masses of silver chloride. Whether you are brushing up on stereochemistry or diving into chemistry problem solving, this video got you covered. Let's assume we are given this kind of problem that says when 140 grams of silver nitrate was added to an aqueous solution of sodium chloride, 86 grams of silver chloride was collected as white precipitate. Which salt was the limiting reactant in this reaction, and how many grams of sodium chloride was present in the solution? How can we solve this problem? So, before we talk about how we can solve this problem, let's take a quick revision. If we are given Ag, this is simply silver. What about Ag positive? This is going to be silver ion. What if we are given Cl? This is chloride. What about Cl minus? This is simply going to be chloride ions. What about Na? This is sodium. What about Na positive? This is going to be sodium ions. What about NO3? NO3 is nitrate. What about NO3 ions? This is going to be nitrate ions. What if in the case where you're given two combinations, since we said Na is sodium and at the right hand side we're given nitrate? How can you call this element? This is going to be sodium nitrate. Let's go back and solve this problem. First, in the reaction equation for the silver nitrate and sodium chloride to form, that is, if we react the silver nitrate, which is AgNO3, and sodium chloride, this is simply going to be sodium. We are going to have silver chloride and sodium nitrate. Let's see the reaction. First of all, we are given silver nitrate and we are given 140 grams of it, and we are given sodium chloride. We are given, that is in the solution of sodium chloride, but we are given silver chloride. In this case, silver chloride is 86.0 grams. Let's see the reaction. If silver nitrate in aqueous solution react with sodium chloride, it's simply going to form silver chloride or solid silver chloride and sodium nitrate in aqueous solution. This equation represents the double displacement reaction where silver ions, in this case, from silver nitrate. Because this is silver nitrate, if we remove this, it's going to be silver ion. At this point, we are ignoring the nitrate. They said this equation represents the double displacement reaction where silver ions, which is Ag positive, from silver nitrate react with chloride ion. At the right hand side here, this is simply going to react. Instead of sodium chloride, at this point it's going to react with chloride ions. These two are going to react. What are they going to form? These two are going to give rise to this, which is what? Silver chlorine. So what are we going to do next here from this point? Here, since we have taken our silver ion, we're going to be left with nitrate, also an aqueous solution, or let's just say nitrate. At this point, our nitrate is going to react with water. At the other hand, we're going to be left with okay, here we have silver ion, silver nitrate. Here we have sodium chloride. The displacement of silver will react with chlorine, leaving the nitrate behind. The nitrate is simply going to react. At this point, it's going to react with sodium, and this is going to give rise to sodium nitrate, also an aqueous solution. So, to determine the limiting reactant in the reaction between, that is, the silver nitrate and sodium chloride, we need to calculate the theoretical yield of silver chloride formed from both reactant, and then identify the reactant produces less silver chloride. So first thing we need to do is to find the molar masses of silver nitrate and silver chloride. So we said we are going to find the molar mass of what? The first element we are going to find is for the silver nitrate, and part B we are going to find for silver chloride. So let's do this problem. We said we are going to find the molar masses of what? Of silver nitrate, and the molar mass of silver chloride. In this case, let's start with the first one. Here we have Ag, which is silver, NO, which is the nitrate. This is simply going to be Ag. I'm going to substitute with nitrogen is on its own, and here we have what? We have 3 oxygen. On the periodic table, silver is what? 107.9, or it's 107.87, which is approximately 107.9, plus nitrogen is 14.01, plus oxygen is 16. But at this point we have 3 oxygen. This is simply going to be 3 multiplied by 16. Remember, at this point everything is going to be in gram per mole. So this is simply going to be 107.9. We're still going to plus it with the nitrogen, which is 14.01. Then 3 multiplied by 16. This is simply going to be 48. Nothing changes at this point. This is still going to be in what? Gram per mole. If you plus everything, the molar mass at this point is simply going to be 169.91 in what? Gram per mole, which is 107.9 plus 14.01 plus 48, everything in gram per mole. This is the molar mass. So what about the moles? So since we have found the molar mass, and we know that silver nitrate, we are giving the mass to be what? 140 grams. So next thing we need to do is to find the moles. In this case, M in what? Silver nitrate. This is simply going to be the mass divided by molar mass for us to find the moles. At this point, what is our mass? Our mass is what? 140 grams divided by our molar mass, which is 169.91 grams per mole. At this point, grams will cancel out with gram. We are going to be left with 140 divided by 169.9, leaving out with moles. Therefore, if you said 140 divided by 169.9, our moles, that is the unit, is simply going to be 0.824 moles. So at this point, next thing we need to do is to use the stereochemistry of the reaction to find the moles of silver chloride that could be produced from silver nitrate. Let's balance the equation. What's the balance equation? This is simply going to be, we have seen the equation previously. Let's balance the equation. Since we have silver nitrate plus sodium chloride, which will give rise to silver chloride plus sodium nitrate. We can add 2 moles here, 2 here, let's say 2 here, and 2 here. At this point, we can conclude and say 1 mole of silver nitrate produce 1 mole of silver chloride, which is, we can set 1 mole of silver nitrate. Join us as we tackle a classical limiting reactant problems involving the reaction between silver nitrate and sodium chloride. We'll also walk through step by step as we calculate the theoretical yield of silver chloride from both reactant and identifying the limiting reactant. In the end of this video, we are going to, let's go back a little bit. In this case, since we said 1 mole of silver nitrate produces 1 mole of silver chloride, which is 1 mole of silver nitrate actually produces also 1 mole of silver chloride. In this case, we can conclude and say moles of silver chloride from silver nitrate is equivalent to the mass which we find. The moles which we find, which is approximately 0.824 moles. Next thing we need to do is to find the theoretical yield of silver chloride from sodium chloride. So first thing we need to do is to calculate the molar mass of sodium chloride. We said we are going to calculate the molar mass of what? Of sodium chloride. In this case, Na, which is the sodium, on our periodic table is simply going to be 22.99 gram per moles. What about the chloride? On our periodic table, chloride is 35.45 grams per mole. For us to find the molar mass, we're simply going to add the sodium plus masses of sodium and the chloride together. And this is simply going to be 22.99 plus 35.45. Always remember, everything is simply going to be in grams per mole. If you join the two together, this is simply going to be, that is the molar mass, it's simply going to be 54.44 in grams per mole. Next thing we need to do is to calculate the numbers of moles of sodium chloride since we have already found the molar mass. the moles. What is the mass of sodium chloride in the given problems? That is what we need to find now. The moles of sodium chloride, is simply going to be the mass. Let's find the mass of silver chloride, and we shall divide it by the molar mass of what? Of sodium chloride. At this point, we can say, what is the mass of silver chloride? We are given the mass of silver chloride to be 86.0 grams divided by 58.44 grams per mole. Gram per mole will cancel out. We're simply going to be left with 86.0 grams. Sorry, 86. Let's just put 86 divided by 58.44. Everything is simply going to be a mole. If you divide 86 by 54.44, this is simply going to be 1.472 moles. So from the stereochemistry, 1 mole of sodium chloride produces 1 mole of silver chloride. Since silver nitrate produces fewer molecules of silver chloride than sodium chloride, in this case we can conclude and say silver nitrate is the limiting reactant. So our limiting reactant is what? Is silver nitrate. Let's take a quick revision. We said 1 mole of sodium chloride produces 1 mole of silver chloride. Since silver nitrate produces fewer molecules of what? Silver chloride than sodium chloride, then we can conclude and say our silver nitrate is the limiting reactant. Next thing we need to do is to find the amount of sodium chloride present in the solution. From the stereochemistry, the molar ratio of silver nitrate to sodium chloride is 2:2, which simplifies to 1:1. So the moles of sodium chloride present in the solution are equal to the moles of silver nitrate, which is approximately 0.824 moles. So next thing we need to do, or the last thing we need to do, is to finally calculate the masses of sodium chloride. And how can we do that? Alright, the mass of sodium chloride is simply going to be the moles of the sodium chloride itself. Then we are going to multiply it by the molar mass of what? Of the sodium chloride. And if you write it down, or if you could remember, we said the moles of the sodium chloride is simply 0.824 moles. Then we should multiply it by the molar mass. The molar mass is what? 54.44 in grams per moles. At this point, I think our moles will cancel more. We're going to be left with 0.824 multiplied by 58.44 in grams, since we're asked to find the mass. In this case, our mass is going to be, if you multiply the two, it's going to be 48.15 grams. Therefore, we can conclude and say this is approximately 48.15 grams of sodium chloride was present in the solution. So this is it for this problem. Thank you for watching. Let's go back a little bit. In this case,